Yeah, I don't want to listen to him. He made me feel worthless.
Well, you don't have to listen to him again, but he can listen to him again.
Yeah.
It's good practice.
Sorry.
So can I start?
No, I wait for your presentation.
So my papers are more about information visualizations. I chose it because of, it might be related somehow to my project. So the first paper here is about how we should deal with visualization of data that has missing values. The different visualizations of data can bias the user's data interpretation, and the question is how we should visualize missing data. Should we highlight the values like this, or should we downplay them? So in this paper, two factors are considered for data visualization. The first factor is visualization techniques. They used highlighting, which is highlighting the missing values, downplaying, which is kind of the opposite of highlighting. It's reducing the salience of missing data, using annotation like error bars to show the missing data, and last, removing the missing information. And the second factor is imputation. There are three methods for imputation. The first one is zero filling, which is assigning a value of 0 to the missing values. The second one is using the means of the rest of the data and assign it to the missing value. And the third one is using linear interpolation to interpolate the missing value. So considering these two factors plus different percentage of missing data and two tasks of averaging and the slope of the changes, these methods are tested on bar and line charts. And the data used here is the average, is the frequency of tweets per minute in 1 hour. And so there are some measurements for quality. The first one is confidence, how confidently the users can complete a task. And the completeness is how much data is available, credibility, how true is the data, and reliability, which is how correct is the data. And so 5 questions were asked from the users. The first one was about the tasks, whether the first half or the second half has the higher average number of tweets or has the higher rate of changes of the tweets. And the second measurement is about how confident you are in your response and how credible, how complete, and how reliable the data is. And so the results of averaging and trending tasks are shown here. This is for the first factor, visualization technique for the line graph. And 1 information removal, 2 highlighting, 2 annotation technique, and 2 downplaying were used. Based on the result of averaging task, we can see that highlighting has higher data quality. There's an interesting point here, is that one method of annotation here has higher data quality, while the other one has lower data quality. And the pattern for trend is not the same, but still we can see that highlighting and annotation has higher data quality. And for accuracy, the changes are very close together. So for imputation technique, we can see that for line graph, we can see that the zero filling technique has lower data quality and accuracy, both for averaging and trending tasks. And the other 2 techniques have higher data quality. And for the differences in amount of missing data, we can see that by increasing in the amount of missing data, the data quality decreases. And for the bar chart, they also used 1 information removal technique, 1 highlighting, 2 highlighting and 2 error bars, and 2 downplayings. The results also indicate that using error bars and bars with error bars have higher data quality, and the same pattern, there's the same pattern for a trend task. And the result for imputation techniques for bar charts and line charts are the same. So you can see that zero filling has the lower data quality, and the two other techniques have higher data quality. And again, the result for bar chart is the same for is the same as the line graph, and with increasing in amount of missing data, the data quality decreases. So in conclusion, we can say that the different imputation and visualization techniques can change perceived data quality and accuracy, and can bias users' data interpretation. And highlighting in the visualization techniques, the highlighting methods leads to higher perceived data quality, and downplaying and information removal lead to lower data quality. And and among the imputation techniques, we can say that the marginal means and linear interpolation have higher data quality, and the zero filling has lower data quality. And
it's
there was
perception of, right?
Excuse me?
Like it's perception. It's not leading to lower data quality. It's leading to the perception of lower data quality, right?
Yeah, you think that the
right the audience believes.
Yeah,
No,
the users might. Yeah. So there was another point that the paper mentions is that these are the visualizations that lead to high perceived data quality, and these are the visualizations that lead to low perceived data quality. And all of these visualizations have one thing in common: is that the visualization discontinuity. And they hypothesized that this might be because the users perceive this as different units and try to do the task by this bias. And so therefore they think that because the first one doesn't have discontinuity, it might lead to higher data quality. And the second paper is about visual adjustment of data grouping. And the data that this paper is using is HIV data, and the researchers are mostly using histograms and bar charts to do this. And their data that they're using is something like this. And they want to have faster interaction with this kind of data. And the method that they are proposing is embedded merge and split, or EMS, which allows data grouping through manipulation of visual glyphs by direct interaction of the users. So the current tools that these users are using is widget-based models like Tableau, or ArcGIS, and programming like SAS or R. And the problems that they face is that it takes a lot of time, and they need to know how to. Requires programming skills, and it also lacks of fast interaction. So the goals of this paper is to reduce the number of steps for data grouping and the gap between interaction and the visualization results. So initially they proposed two designs, but one of them was chosen based on these goals, and the user said that this design has less steps. So this design was chosen, and then the main features that EMS technique is providing is the first one is merge, which is just merging the intervals together. The second one is splitting, which is opposite of merging, and also changing the number of intervals. So this is how EMS works. For histograms, if you want to merge the histogram, you can just select one interval and then drag it to merge it with the right one or the left one. And if you want to split the groups, you can simply select the interval and drag it to the right or to the left, and you can simply split that. Split it into two groups here. And the last one is changing the number, which you should first select all of the intervals, and then it shows you the number of bins, and you can drag it to left or right to increase or decrease the number of intervals. For bar charts, it's relatively the same. You can just drag the different charts together and merge them together into or more groups. And the second one is splitting, which is you can drag the group that you want on the x-axis, and then you can split the groups. Okay, here all of those three were split. So for the evaluation, they conducted two studies. The first one is quantitative study, which they assess the performance of the model compared to the widget-based models. And the second one is qualitative study, which simply just getting feedbacks from the users. For the quantitative study, they wanted users to compare the avant-garde tool, which is using the EMS technique in that, and the Tableau Public, which is a widget-based tool. So the result of the quantitative study showed that users were faster on average, were faster with the EMS model. So EMS is supposed to be faster than widget-based models. And for qualitative studies, the writers asked the researchers to use the EMS tool for their own analysis in 30 minutes. And based on the feedbacks that they got from these researchers, the advantages of using EMS was consistency with a user's mental model, so it's an intuitive model. And it seems seamless, and it has a fluid interaction because it reduces the number of steps, and you can see just what you visualize in a second. But the disadvantages of this model was that it was difficult in selecting small intervals and overlapping targets. So in conclusion, we can say that EMS reduces data grouping process, and it reduces the number of steps and time to group the data. And it also provides feedback about users' changes. You can see when you change the number of intervals, you can immediately see how it works. And future steps in this paper, the more important ones was extending EMS for other visualization types, such as pie charts or parallel set visualizations, and to extend EMS for multivariate data visualization. There are also three more future steps in here. The first one was using EMS for trellis visualization, which is the x-axis of the chart or the histogram is the same for the data, but the y-axis, the feature is changing. So they want to see if the user changes one feature, if it's going to change in another feature or not. And the second one is defining new groups that they were not present in the first data set, and using EMS on touch-based devices. These are the future steps. And so we go back to the third paper here. The third paper is visualizing collective behavior. It's using collective behavior of fish movements, and they are using spatial indexing to abstract the spatial dimension of the data. So for collective behavior, like fish swarm of fish and their movement in space and time, there are some possible solutions, but they have some disadvantages. Like you can use animation, but if the time aspect is very long, the animation will become tedious. And aggregation can be used, but we will lose the individual behavior information. We can use small multiples, but we will lose what happens between the intervals. And finally, we can also use space-time cubes, but space-time cubes will become chaotic when using large data sets. So the ideal solution for visualizing spatiotemporal collective behavior is to include both space and time, and have a compact visualization and allow comparison of different times, and also emphasize on the changes. So the methodology is of this method is
should be okay.
Yeah. So first, just consider one data frame, one time frame. We have some movers, and we okay. Oh, it's gone again. Okay. So suppose a single time frame now. For now, we have several movements, and we have a feature like speed, and we can apply a Hilbert curve, for example, on this data to make a one-dimensional linearization and to compact the spatial component. So this is a Hilbert curve. And for example, if we take 7 points of these movers here, we can apply the Hilbert curve on these 7 points. And we can have a sequence of the points here. So this is the first point that we are trying to traverse, and the other points. And if you put it in a pixels here, and then we apply their feature by its color, so we can get a slice of the linearization. And then if we repeat this process for all of these frames, we get multiple slices from the first time step until the last time step. And if we put all these slices together, if you put X on time and Y on space, and if you put all these slices together, it seems like we're weaving a rug, and that's why it's called motion rug. And so we get something like this. So the key aspects of this method is space partitioning and transformation, which what I said is the use of spatial indexing methods like curve filling method, like z-orders and Hilbert curve, and the other is tree-based structures like R trees and quad trees. And the second one is strategy selection, selecting between all these methods, which one is better. And the last one is feature encoding and visual interpretation of the motion rug. So the visual interpretation, so this motion rug can have different interpretations. As you can see in this visualization, there are three different interpretations. The first one is spatial change, which is the changing the direction of the movers. You can see it here, the direction is changing, and here it is speeding up slowly, and then all of them have high speed, and then they are slowing down. The other one is a trend, which is started by a few number of movers, and then all the movers are joining in this trend. Or it can be the opposite way. A lot of the movers are having a movement, and then it's stopped until a few number of them have that movement. So this is how the trend looks like. The trend starts here, and few are starting this trend, and then it's ending here, and until all of them join this movement. And there is another another interpretation, which is called the spatial stagnation, which is simply just turning around one point. Here you can see that they are not having overall spatial movement. They're just turning around one point with a low speed. And looking at the differences between the spatial indexing methods, we can see that the Hilbert curve, the z-order, and point quadtree methods have somehow similar visualization, but the R-tree seems a bit confusing here. It's because the way R-trees are making the one-dimensional linearization, and there might be some points in the real space that are close together, but the R-tree does not keep this structure as close as the other methods. So it might be possible that that 2 points that are close together in the real space are not close together in R-tree and fall into different branches. And if you look at the table of results, we can see that the crossing and the skips and the Kendall's tau is much. The Kendall's tau is less for R3, which shows the correlation, and the crossing and the skips, which shows the which is higher for R3. So it shows that R3 is not very useful for spatial indexing in motion rods. And if we stretch the motion rag like this, and then we map the vertical movement of the movers, we can see there are less number of jumps in Hilbert curve than R3. There are a lot of jumps in R3s. And as we know that the fish don't move very instantly, we are sure that this is the problem with R3s, that the way that they are indexing the space aspect. And there are also some artifacts in the motion rod. The first one is these artifacts that is changing of the movements by a few units. And there's also a phantom split. And this is called phantom splits because it's not a behavior of the movement, of the collective behavior, and it's because of the way the indexing is taking place, because of the spatial aggregation function or differences in the feature distribution. So both of these artifacts are from the visualization and not from the behavior. And the conclusion of this paper is that motion rods present spatiotemporal collective data by abstracting the spatial dimension and focusing on overall behavior. And the different features can be visualized using motion rods. It can be speed, it can be acceleration, it can be heading change, and also the distance of each fish from the centroid in one frame. And there could be possible ambiguity of positions and directions of the entities, and using Hilbert curve is the most suitable partitioning strategy because it has less number of less artifacts and showed better results in the table in maximum crossings and jumpings, and R3 is less useful. So the next step in this paper is using more ordering strategy and using separate data groups on just one collective behavior, and enabling interactive exploration so that if a user click on one part of the motion rod, it can see the individual time frame of that time. And that's all. Should I take this off, or?
So this was quite I mean, there's been a lot of the same going on in terms of trying to do spatial temporal visualization. So this was really different from anything that I've seen before. It's kind of, the abstraction is so dramatic though. You really have to train yourself to read these things. So.
We learned about spatial indexing previous semester.
Yeah.
Course,
I mean, that's easy to understand, but the mapping of the rug to what it needs is challenging.
Yeah.
And I think when they add ability to scrape across it and see the frames, then it'll be stunning.
Yeah.
It'll be really great.
But I think there is still the problem with the time aspect remains, because if you have like, I don't know how, what was the time step here, but it really depends on what the time step you choose. Like, if you have an hourly data, what is your time step? 1 minute, 2 minutes, or more. So it can be also tedious if you have a large number of, if you have a large time aspect. I think the problem still remains here, but they didn't.
They can still slice, I think. I mean, even if the data is big and you want to make it more interactive, or the feature scope, I think you can still slice. And that's what the work on Omni side we did for the vessel data. So I think you can still do that with larger data having.
So I think you should, choose bigger time steps, right?
That you can still play with it.
Yeah, or yeah.
It'll be interesting to see your vessel.
I don't think I remember
Yeah,
seeing anything
I
about
remember
helping you identify the phantom splits, like the artifacts. Was there any, did it mention anything about helping the user?
To find the artifact? No, it's just it showed the paper and then it said that, okay, here if you zoom in, we can see the artifacts. But I think if you want to determine any artifacts, you should just look very closely and identify that. I don't know.
Seems like it would be hard to distinguish
maybe.
what's real and what's phantom.
Yeah, unless you know it.
They mentioned that this was like a really highly specialized research area and that not a lot of people like study this stuff, so they even had trouble finding people to test it on. So, I mean, if there really aren't that many people doing it, only a few people really need to understand it. Maybe it would be helpful to those few people who really struggle to visualize the specific thing that they work on.
I don't know if I interpreted the diagram correctly. Does an entire row represent one single page?
No.
No, it's not one.
Yeah.
It's the whole group behavior.
In that case, can I identify one single fish moving?
The purpose of the study is to collect, to visualize the collective behavior. So it will be out of the scope of the paper, I guess. But
If you have the interactive version of it, then probably you can choose one of ID specifically. But then this is not the purpose of this. Can you go back to the EMS one?
Should I pause it?
Yeah.
EMS.
No, should I pause this? Or?
No, it's fine.
Okay.
The comparison between the future work, Tably one.
You mean the table or?
Go back one.
Okay. Again or?
Yeah, so the comparison between the Tableau on the future work of this is what did he say there?
There were some tasks about changing the number of intervals, merging and splitting, and the users had to do it in both Tableau and Avantgarde. And Avantgarde has that EMS label. So they recorded the time that the users are doing the tasks, and so this table is showing the average and the standard deviation of the time.
WNP is Tableau? Where is Tableau?
Yeah, it's widget based.
The first,
The widget.
the Vim model is Tableau.
Okay. And go to the next slides.
This one?
Next slide. Yeah. The previous one.
This one, you mean?
I think here you're saying that they want to integrate more chats and pie.
Yeah, right now they're just using histograms and bar charts. So they want to do it for pie charts and parallel visualization. It should be the same. If you can drag it like this, it might be the same.
Just an implementation challenge.
Is it Tableau, the evaluation that they have done for Tableau says the time taken on Tableau is more than the EMS, some are not convincing to me.
You know, in Tableau, you have to, like, there are several steps, they said in the paper, I guess, that you should take several steps, and then you, like, select.
Or if someone knows that, he can.
Yeah, I mean, yeah, it will be easy, but it has, this one has faster interaction. It doesn't need any knowledge, you know, it doesn't
Well, you
need
have
any
to
knowledge.
leave the dialogue. You have to leave the visualization to do it. And so WIMP stands for window, icon, menu, pointer. So you have to go into different menus and then type numbers probably, right? Instead of stretching it to the width that you want.
And you can integrate that with.
So it's not like as direct.
And,
You're not
yeah,
working
I like
right
that,
on
yeah.
the living room.
Very no, I was given 0.